Every day, our water sources face invisible threats: pollution, changing density, and declining cleanliness.
Welcome to Hydroflux, where science comes alive in 3D. Ever wonder why some things float while others sink? Let's explore density together. Plastic, oil, and styrofoam float because they're less dense than water. Watch sedimentation in action as particles settle based on their weight. Filtration separates particles using different materials to clean water. Explore multiple learning stations with hands-on experiments. Access Hydroflux on any device, laptop, tablet, mobile, or VR headset. Start learning today, completely free, no installation required.
Hi, my name is Rachel, and this video presents of my individual analysis for our group project titled Hydroflux, a 3D interactive science environment developed on the Spatial platform. My role in this project focused on the instructional design, visual arrangement, and the user experience flow within the virtual learning space. I contribute to shape how pupils move through this environment, how information is presented visually, and how each station connects to the science concept of density. One of my main creative contributions was designing the 4-stage scientific journey pathway that structures the Hydroflux world. Instead of placing interactive objects randomly, the learning experience is arranged like a guided journey. First, Density Discovery Zone, where pupils first explore floating and sinking through the simple drag and drop activity. Next, Buoyancy Exploration Area, where the object properties can be manipulated to test scientific prediction. Thirdly, Pollution Observation Chamber, where density concepts are linked to different types of pollutants. Last but not least, Filtration and Sedimentation Lab, where the concepts are applied to real-world water treatment. This pathway is creative because it transforms an abstract science chapter into a story-like adventure, allowing pupils to discover, experiment, connect, and apply knowledge in sequence. The design also uses color coding, simplified visual icons, and animated arrows to show invisible forces like buoyant force. These elements reduce cognitive load for young learners and support dual coding principle. Our creative intention was to make the science concept more intuitive, especially for pupils who struggle to understand density through textbook alone. The water clean theme became meaningful because the pollution chamber and filtration lab show exactly how density affects environment cleanliness and helping pupils to connect science to real-life water issues. Ban Hydroflux and make it marketable educational tool, I propose a 3-part strategy focusing on accessibility, scalability, and long-term sustainability. First, premium educational model. Hydroflux can remain free to access on Spatial, but additional learning materials can be packaged as optional add-ons such as printable experiment worksheets, teacher lesson plan, student activity books, premium interactive missions. This model keeps the core learning world accessibility while generating revenue for continued development. Secondly, school-based adoption strategy. Hydroflux is aligned with the DSKP Year 3 and Year 4 science standards. This alignment makes it suitable for classroom science lessons and STEM week events, and also enrichment of classes and environmental awareness programs. Teachers only need a browser and an internet connection, which remove financial and technical barriers. Thirdly, community and NGO partnership. Because HydroFlux supports SDG 4, which is quality education, and clean water literacy, it has a very strong potential for collaboration with environmental NGOs, CSR education programs, and also STEM competitions and grants. And these partnerships allow this project of HydroFlux to reach rural areas of schools and also low resources communities. And the strategy position HydroFlux not only as a digital learning world but also as a sustainable educational ecosystem that can grow through modules, workshops, training, and expansions packs. It has a long-term impact because it supports science learning while promoting awareness of water cleanliness and environmental responsibility. This project taught me that creativity is not only generating new ideas, but about designing learning experiences that solve real classroom problems. Working on HydroFlux strengthened my ability to think strategically, especially in blending structures that are both educational and commercially realistic. Overall, this project helped me grow in instructional design, problem solving, and digital learning innovative that will continue to be useful in our future educational projects.